All right, chapter 6, section 1, graphing quadratic functions. So, a quadratic function is an equation of the form f of x equals ax squared plus bx plus c. And remember, f of x is just a fancy way of writing y equals, and it also tells us that it's a function, meaning it'll pass the vertical line test. So, ax squared is the quadratic term, bx is the linear term, and c is the constant. The graph of any quadratic function is always a parabola. So this whole unit we're going to be talking about parabolas. All right, number 1 there says graph f of x equals x squared plus 3x minus 1 by making a table of values. I'm going to get the table of values from my calculator. If you don't have a calculator, remember you're just plugging things in. All right, so in my calculator, I'm going to type in x squared plus 3x minus 1. And then I'm going to look at it, second graph. All right, there's my graph. So I know from this guy that it's over here on the left-hand side of the origin, so I know I need to grab some negative values. If you don't know, make sure, if you don't have a graphing calculator, make sure that when you're plugging numbers in, you grab some negatives, you grab some positives. I would do at least -2, -1, 0, 1, 2. That way you get a good estimation or a good picture of what's going on. So let's look at our table of values. I'm going to use my table of values, and I'm going to grab the nice, pretty ones that are easy to see. So maybe -4 and +3, and -3 and -1, and -2 and -3, -1, -3, 0, -1, and 1, 3. All right. Like I said, if you don't know, you're plugging them in. That would be -4 squared plus 3 times a -4 minus 1 more. 16 minus 12 would be 4 minus 1 more would be 3. So here we go. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. -1. 1, 2, 3. Somewhere in between -1 and -2, we have a vertex. Every parabola has what's called an axis of symmetry. So the axis of symmetry is the line through the parabola that where it's folded makes both sides overlap each other. Meaning, if I were going to fold this guy in half, the axis of symmetry would be right there. Okay? So I could fold it in half, and those two halves would line up on top of each other. The vertex is the point where the axis of symmetry crosses the parabola. So this point right here is the vertex. So there's some special things if we look at just the equation. So if y equals ax squared plus bx plus c, then c is the y-intercept, which we can see right here. My c was -1. It crossed my y-axis at -1. The equation of the axis of symmetry is x equals -b over 2a. Okay? That's the equation of that orange dotted line right there. The x-coordinate of the vertex is -b over 2a. Look at those for a second. I have x equals -b over 2a and just -b over 2a. They're the same. Okay? The x-coordinate of the vertex is just a point. He's half of an ordered pair. The equation of the axis of symmetry is a line. Okay? So yes, they are the same. But, and I'm going to abbreviate axis of symmetry, AOS, is an equation. Because it's a line. Okay. So let's use that information and see what we can do here. Number 2 says use the quadratic function f of x equals 2 minus 4x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Alright, well, this one's not exactly written in the most pretty of order. Normally, we write it with the biggest exponent first. X squared minus 4x plus 2. Okay, that being said, remember that we can write it as ax squared plus bx plus c from the top. So, a is my coefficient of my x squared term. I'm going to go ahead and label what a, b, and c are. B is the coefficient of my linear term, so negative 4. And c is my constant, so 2. Alright, now, from our bullets up here at the top, it says c is the y-intercept. Okay, so the y-intercept is positive 2. The axis of symmetry. That's x equals negative b over 2 times a. Okay, well negative b would be negative 4 over 2 times 1. So positive 4 over 2, or x equals 2. The x-coordinate on my vertex is just 2. Meaning if I were going to do the ordered pair for my vertex, it would be 2 comma something. Okay, well let's figure out what that something is, because part B says make a table of values that includes the vertex and use this information to graph it. Alright, in the middle of my table, I want to use the x-coordinate of my vertex. And then I'm going to plug it in. Alright, that's 2 squared minus 4 times 2 plus 2. So 4 minus 8 would be a negative 4. Negative 4 plus 2 is a negative 2. Alright, so I know I have an axis of symmetry of x equals positive 2. The x-coordinate of my vertex is at 2 comma negative 2, so there's my vertex. And now we also know that the y-intercept is positive 2. Okay, there's a point there. The axis of symmetry makes it fold into 2 equal halves. So if this guy's 2 over from the axis of symmetry, this guy will be 2 over from the axis of symmetry. Alrighty. Now, let's fill in some other things. So, we knew that 0 was at positive 2. That means that 4 is also at positive 2. Let's fill in the ones in between, 1 and 3. Alright, when I plug in 1 squared minus 4 times 1 plus 2. 1 minus 4 is negative 3. Negative 3 plus 2 is negative 1. That means 3 will also be at negative 1. And there's my parabola. We could also throw this guy into our calculator, and we should see the same table of values. Okay, so if I plug this guy into my calculator, x squared minus 4x plus 2. Hit graph. Let's make sure he matches. Looks the same to me. Second graph, I'm going to look at my table. Here we go, 0, we were at 2, 1, we were at negative 1, 2, we were at negative 2, 3, we're at negative 1, 4, we're at positive 2. So when you're making a table of values, we always put our vertex in the middle, and we get that middle term by doing the x-coordinate of the vertex and the axis of symmetry. Okay? All right, turn the page. Let's do another one. Number 3 says, use the quadratic function f of x equals negative 2x squared plus 8x minus 3. Again, find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Okay, that guy's written in nice pretty order, so let's figure out what a, b, and c are. A is the coefficient of my quadratic term, so he's negative 2. B is the coefficient of my linear term, so he's 8. And c is my constant, so negative 3. Alright, so my y-intercept is my constant, so that guy's negative 3. Axis of symmetry, x equals negative b over 2a. Okay, x equals negative 8 over 2 times a negative 2. So negative 8 over a negative 4 gives me a positive 2. So x equals 2. The x-coordinate on my vertex is also 2. Alright, my table of values. Positive 2 goes in the middle. I want two numbers that are smaller, two numbers that are bigger. You're graphing a total of 5 points every time. Alright, we also know that at 0 it will be negative 3, so at positive 4 it will be negative 3. 1, 2, 3. My axis of symmetry is at positive 2 again. X equals positive 2. My vertex, if I plug it in, negative 2 times 2 squared plus 8 times 2 minus 3. Order of operations, exponents first. 2 squared is 4. Times it by a negative 2 will be a negative 8. Negative 8 plus 16 is 8. 8 minus 3 is 5. So my vertex is at 5. What else could we do? We could put it in our calculator. You've got it. Let's use it. Negative 2x squared plus 8x minus 3. Second graph, look at my table. 0 is at negative 3. 1 is at positive 3. 2 is at 5. That's what we found. 3 is at 3. You'll notice that this guy opens down now. He's also a little bit skinnier than the last one. That's because this coefficient out front here is different. He's a negative 2. The coefficient, our a on the first one, was 1. All right. The next thing it says there, the y-coordinate of the vertex is called the maximum value or the minimum value of the function. Meaning, if I look at this graph right here, this guy doesn't get any taller than 5 on the y-axis. And this guy over here on the front doesn't get any smaller than negative 2. So, the graph of f of x equals ax squared plus bx plus c opens up and has a minimum value when a is greater than 0, or when a is positive. The graph of f of x equals ax squared plus bx plus c opens down and has a maximum value when a is less than 0 or when a is negative. So this guy right here has a maximum value of y equals 5, but he doesn't have a minimum value because he goes forever and ever and ever and ever. He's going down this way forever and ever and ever. Okay? He's going towards negative infinity. This guy has a minimum value, but no maximum value because he's going to go forever and ever and ever towards positive infinity. All right. So based upon that information, number 4 there says for f of x equals negative x squared plus 2x plus 3. Determine if the function has a maximum or a minimum value and state that value. Okay, so let's look at it. My a value. My a is negative 1, my b is 2, and my c is 3. Alright, it said when a is negative, it opens down, so this guy opens down, and has a maximum value. Now, it said find that value. That value is the y-coordinate of my vertex. In order to find the y-coordinate of my vertex, you have to find the x-coordinate first. Okay, so the x-coordinate of my vertex. Negative b over 2a. Okay, negative 2 over 2 times a negative 1. So negative 2 over negative 2. So a positive 1. Now we have to find the y-coordinate of my vertex. And we're going to plug it back in. Negative 1 squared plus 2 times 1 plus 3. Now, the negative is out front, so be very careful, because this is positive 1 squared times it by a negative, so that would be negative 1 plus 2 plus 3, for a grand whopping total of 4. So, my vertex is at the point 1, 4. My maximum value is 4. It's the y-coordinate of the vertex. Guess what? Your calculator can give you that maximum value or the minimum value. You have to graph it first to know what you're looking for. But let's go ahead and do that with this one. Alright, so the first thing I'm going to do is I'm going to put my function into my calculator. So I'm going to use a negative sign, not a subtraction sign. X squared plus 2x plus 3. Let's graph it. We know it should open down and we know it should have a max value. So let's graph it and just double check. Hey, look at that. It opened down and it's got a maximum value. And it looks like it's about at 4, so we probably did a good job. Now, you have a whole bunch of menus here with your graph. So I'm going to go to this calc menu here. So I'm going to do second, trace. And look at what it asks you. It asks you, we could find a value, a 0, a minimum, a maximum, or an intersection. Well, we're looking for a maximum. We knew we had to find a maximum. So you have to graph it first to know if you're looking for a maximum in. Alright. Now, I have my little, I call him my spider. He's blinking. My little spider is blinking right there. And when I move left and to the right, see how he moves along my graph. Okay? If you had more than one thing graphed, the up and down arrows would switch between the graph. So, this guy's moving along my graph. Now it's asking you a question. It's saying the left bound. You need to put your spider on the left side of your maximum, or the left side of your vertex. It doesn't matter where. We're just saying somewhere, this is the left bound of my vertex. Alright, so I'm going to push enter, somewhere on the left side. Move my spider, because now it's asking me for the right bound. Move him to the right side of your maximum value and push enter. See how it put 2 dotted lines in there? We're telling our calculator to look somewhere between these 2 lines. We should have a maximum value. And then your calculator says, should I guess? Yes, please calculator, guess for me. That's why I'm having you do it. Hey, looky there. It says the maximum value is at 1,0,0,0,0,0. Now it's doing a whole bunch of math in the background, and sometimes we get a whole bunch of zeros. That's essentially 1, 4. Your maximum value is your y coordinate. So we did great. Okay? So again, you can use your calculator as long as you know which way it opens, up or down. Do second, trace, and you can find the maximum or the minimum. There is another sheet there on Canvas that it says calculator moves, and it tells you all about which ones to do, and it gives you a nice pretty picture, tells you which way to go. Okay? Tells you which buttons to push. It's called TAG 61 calculator moves. But there's a whole document there. I wrote it out. Tells you which buttons to push. The Y value at the bottom of your screen is the max or the minimum value. Okay? All right, last one, number 5. Number 5 says, for f of x equals x minus 2x squared minus 1 determines the function has a maximum value or a minimum value. State the value. All right, first of all, let's put it in the correct order. So f of x equals negative 2x squared plus 1x minus 1. I'm going to state a, b, and c. A is negative 2, b is positive 1, c is negative 1. Look at your a value. A is negative. When a is negative, I have a maximum value, and he opens down. Okay, now we have to find the vertex. The x coordinate of my vertex. Negative b over 2a. So negative 1 over 2 times a negative 2. Or negative 1 over negative 4, positive 1/4. Leave them in fraction form. It'll make your life easier. Some of you don't believe me, I know. Now I have to find the y coordinate of my vertex. Plug him back in. Essentially, we're doing f of 1/4. So negative 2 times 1/4 squared plus 1 times a 4th plus 1 more. 1/4 squared is 1/16. So negative 2 times 1/16 plus 1/4 plus 1. 2 times a 16th is negative 1/8. Looks like we better get common denominators. Negative 1/8 plus, that's going to be an 8, that would be 2/8 plus 8/8. Is that a plus one? Oh, that's a minus. Those are all minuses. So, negative 1/8 plus 2/8 is positive 1/8. Positive 1/8 minus 8/8 is negative 7/8. So my max value, let's do the vertex first. The vertex is at 1/4 comma negative 7/8, and my max value is negative 7/8. Alright, so let's look at your homework, your worksheet. So go back a few pages. At the bottom, it says 6-1 at the top. At the bottom, it says page 315. So for the first ones, 1 through 6, it says for each quadratic function, find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. So you're looking for A, B, and C. You're going to tell me C is the y-intercept. You're going to do that formula for negative b over 2a. Your equation of your axis of symmetry is x equals that, and your x-coordinate of your vertex is just the number. Okay? Now, look at number 1. It seems to be missing some parts. If it's missing something, put in a 0 placeholder. So this guy would be 3x squared plus 0b plus 0, if that helps you. So for number 2, it would be x squared plus 0b, or 0x, excuse me, that should be an x, plus 1. I was thinking b needs to be 0. Okay? For number 7, 8, and 9, you're finding the y-intercept, the equation of the axis of symmetry, and then the x-coordinate vertex, just like you did at the top. Make a table of values. If you use your calculator, I don't need to see your table of values. That's perfectly fine. And use this information to graph the function. I do want you to do part A. If you use your calculator to do B and C, make sure you transfer it to your paper correctly. Okay? No sloppy graphs. Then finally at the bottom it says determine if the function has a maximum value or a minimum value, then find the max or minimum value. If you want to use your calculator to do all of that, you certainly may. So if you want to type this into your calculator, you know he opens up, you're going to go to your minimum on your calculator, and you're going to tell me what the y value is. This guy opens down, so he's going to have a maximum value. You're going to tell me the y value of your vertex. Okay? So these guys, you're telling me max or min, and then what the y value of the vertex is. Alrighty, that's graphing quadratic functions.